In this section, we are going to talk about the evolution of AI. So the question might come in your mind, if the machine learning was already working, why did we spend billion of dollars developing the deep learnings? So the key points here are, if you go back to 1950s, the idea of building machines that can basically mimic human intelligence, mostly based on the predefined rules and the logics. Then it comes to machine learning, and that era was 1980 to 2000. Instead of manually writing rules, computers learned patterns from the data. It worked well for the structured data, but struggled with the complex tasks like image recognition, speech, and the natural language. Then comes deep learning, 2012 onwards. It uses deep neural networks to automatically learn complex features from massive amount of data, enabled breakthroughs in the computer vision, speech recognition, large language models, and autonomous driving and the generative AI. So the key takeaway is deep learning didn't replace machine learning because ML failed. It was developed because many real-world problems were too complex for traditional machine learning to solve. Neural networks are inspired by the human brain. Everybody knows about it. In a human brain, the brain basically contains around 86 billion neurons. Each neuron receives signal, process it, and passes the information to other neurons. This is going to be the exact scenario what we are going to discuss. For example, when you see a dog, million of neurons work together to recognize a shape, color, movement, size. Within a fraction of the second, your brain says, that's a dog. But what happens inside the artificial neural network? Instead of biological neurons, we create artificial neurons. Those are called nodes. The next terminology is connections, synapses. Neurons are connected through synapses. Every time you learn something new, those connections become stronger. For example, the first time you drive a car, it might sound difficult. After driving for a month, your brain strengthens those neural pathways. Driving become automatic. Very similar to if you implement the same concept here in the neural network. Artificial neurons are also connected to each other. They are connected to each other by weights. Weights determine how important is this input. During training, these weights continuously changes until the model starts making the correct predictions. In this terminology, the third thing is going to be the learning. Humans learn through experience, practice, feedback, mistakes. For example, if a child touches a hot cup once, the brain remembers hot objects can hurt. The next time, the child avoids touching it. In very similar way, in the neural network, the network learns from the data. For example, you can show it 1000 cat images, another 1000 dog images. Initially, it guesses randomly. Every mistake is used to adjust the weight. After thousands of examples, it learns the difference and start predicting correctly. The fourth one is going to be the decision making. Your brain basically combines memory, experiences, current information before making a decision. For example, dark clouds plus thunder plus previous experience. The suggestion will be take an umbrella. Very similar to in neural networks. It combines learned pattern from the data to make predictions. For example, if you upload a chest x-ray, the model may predict if you are healthy or possibly a pneumonia. A neural network doesn't think like a human, it imitates one important ability of the brain, the ability to learn from experience. Instead of strengthening synapses, it adjusts mathematical weights. That's why we say neural networks are inspired by the human brain, but not the exact copy of it. Take a look on the slide. We already talked about how this is inspired by the human brain. The next question you might ask, are all neural networks the same? An answer is going to be no. Different problems need different neural network architecture. Imagine you are building AI for WhatsApp voice messages. Which data are you working with? And the answer is going to be is audio. But the same network used for recognizing the cat in a photo works well here. And the answer is going to be no. That is why AI researcher created a specialized neural network. Each architecture is designed to handle a particular kind of information efficiently. So a neural network is like a expert. Different experts solve different problems. So different neural network architectures were created for different type of data. Think of neural network as a family. So you can see there are many. Each member of this family has a specific job. So if we talk about the first one, which is the ANN, which is called artificial neural network. ANN is the simplest type of the neural network. It is commonly used for the structured or the tabular data, such as predicting your house price, loan approvals, or the customer churn. If you go for the next one, DNN, which is deep neural network, a DNN is simply an ANN with many hidden layers. And we are going to talk about these layers, hidden layers, the number of neurons going forward. So adding more layers allow the network to learn more complex pattern, which is why it is called deep learning. So what we are going to solve here, kind of the fraud detection, recommendations. Then comes to the third one, CNN. CNN is especially designed for images and the video. It can automatically detect features like edges, shapes, eyes, and faces, making it ideal for the image classification and medical imaging. Then RNN, recurrent neural network. RNN is designed for the sequential data where the order of the information it matters. For example, you can include speech, text, time series data. Then long short-term memory, LSTM. LSTM is an improved version of the RNN that can remember information for the longer period. It is useful for the language modeling and the speech recognition. And this is nowadays the most famous one, transformer. Transformer are the foundation of modern generative AI. Models like ChatGPT, Gemini, and Cloud are based on transformer architecture, which can process long sequence efficiently. Then the last one is basically GNN, which you can call graph neural network. GNN is designed for graph structured data such as social network, recommendation systems, and can be used for the fraud detections as well. This is going to be the simplest diagram for ANN. What you see here is the input layer, and you see the four neurons in green. These are the values which comes from the feature. Then you see these arrows. These are the connection between the neurons. This is your hidden layer where you see the five neurons, and this is the output layer where you see the three neurons. So this kind of the architecture which basically you can use for detecting the bank transaction fraud, predicting for house pricing, images. Let's try to understand how AI basically makes the decision. So the piece of the information or the feature becomes the input. So for example, if you are putting or training your data based on one Excel sheet which has multiple fields, those are important for the consideration. For example, if the Excel sheet is for the house prediction, it might have features like location, size of the house, the number of bedrooms, and the age of the building. So these points, basically X1 you can consider this is your location, X2 you can see the size, this X3 can be your bedroom, and X4 it can be the age of the house. All the magic starts on the hidden layer. Then it's going to predict output. So what we are doing input of the data, then forward propagation is doing the prediction. It calculates the error and the loss, and then there's a back propagation, update the weights. And this weight is randomly assigned and calculated for these connections. So every connection will have some weight, and these weights get adjusted while you train the model based on the feedback until it starts predicting the right output. This was the data in the Excel sheet we used when we were using the ML, and I'm going to use the same data with ANN. We had 8 features. Those are getting transformed to the same neurons, means 8 neurons on the input layer, and those were the median income, house age, average room, average bedrooms, population, average occupancy, latitude, and longitude. Then these neurons are going to connect with the hidden layer. So you see the number 6. So on the hidden layer you have 6 neurons, and on the output you have only one neuron because this is the only value which we want to predict. Let's take a very simple example here. I'm going to use these as an input value, or my input values are x1 is going to be the size in square feet, then you have bedrooms, then the age of the building, and the distance from the city center. And then you see the biases here. So weight decides how important each input feature is, while the bias is the additional learned value that shifts the neuron's output up and down. Both weight and the bias starts as a random number and are automatically adjusted during the training until the neural network starts making the accurate predictions. So this is going to be the formula how H1 is going to calculate the value, and here you can see the value as well. So the value you see is 0.4 into 2000, and 2000 comes basically from your size, and then you have a weight. Weight for this connection is 0.4. So this is how this is going to calculate some value for H1 layer. And again, when these hidden layers are connected to output neurons, these connections, they will have some weight. So after calculating H1 value, H2 value to H5 value, it is going to calculate the output value. And the output value is something like this. This is H1 value. This is the weight. So the final value is going to be the H1 value into weight. So here you see the results. And if you combine all these results all together, that is going to be your final predictions. So I'm not going to get into the mathematical formula and all those things, but this is how it works. You can also use ANN for fraud detection. So your input layers or the features basically becomes your transaction amount, the time of the transaction, the category, what is the current location, your device type, IP address of the machine from where the transaction is happening, customer age, and the previous transaction. So all that becomes as a feature. Those are going to be the input for the input layer. Then again, some magic will happen and you are going to see the weight get assigned to these connections, and this is your hidden layer. And then you are going to predict what is going to be the final output, whether this transaction is fraud or this is the legitimate transactions. Thank you for watching, and I will see you in the next episode.